Welcome to the seminar on technologies which are trying to solve the problem of toxicity rise in the world. And we saw the simple cases in South India. Um, and for the case study, we took some industries, factories, and then the industry specific to such problems, mm, not in the large scale but in the small scale. So, in the major scale, all industries are contributing to the toxic substances, not just one industry. And where people are more and population is more, they are also contributing to exhausts. So, it is the contribution of all. We cannot say one particular person or one particular firm is contributing to such major disaster, but we can also reverse our theories on maintenance and uh, uh, caretaking the existing infrastructure. We have to reverse the theories, and the infrastructure is not a proper infrastructure. Even though I said that we have world-class infrastructure in certain areas, in the end, they are also going to contribute to the same type of exhausts, and they have to be managed. Now we want to see some of the features of the electronics industry. Electronics has produced lot many materials. One can say that the electronic industry is reliant on certain products like transistors, diodes, then chipsets, ICs, and plastic materials, and then metallic linings, coatings, wires, then congregation of some heat sinking, fire retardant technologies, and fire radiating technologies combined to solve the heat distribution problems within a particular housing. When I say housing, it is the housing of electronic components or electronic chipsets. So, electronic industry mainly produces the components, electronic components, which are needed for some circuits and some systems. The systems have got many units in them, but the electronic industry relies on many other industries. For example, what I have on the hand is a Intel chipset ATX motherboard. Here you can see the motherboard comprises of a metallic layer heat sink which is mounted on the microprocessor, which is inner, and you can see some plastic peripheral interfaces. You can see these are bus interfaces, and they are interfaces for other chips, add-on chips, which can be inserted on this particular plastic casings. And similarly, we have the plastic cases for interfaces, bus interfaces. Buses are wires which are going to carry information from one place to another. So you can see that metallic fitting and a proper metallic manufacturing is contributing to the advancement in the electronics. And you can see that the architecture in the plastics engineering is also contributing to the advancement in electronic engineering. However, we have to address one more problem in the particular manufacturing of all these motherboards, chipsets. When they are worn out, they are being thrown in the dustbins, or being thrown to the companies, or being sold to some other person, or they are sold for spare parts. But when they collect the spare parts, what they are going to do is they are going to remove what you can see here. They are going to remove the regulators. Can you see now? What I show is a regulator. You can see the regulator here. Regulator is, they will reuse this regulator. They will try to reuse this lithium, but they cannot remove this Intel chips and this Intel ATX motherboard, which was my first computer. It was my first computer with the Intel ATX chip motherboard, and unfortunately, due to my mishandling, it got burnt. The chipset got burnt in these areas. The memory card slot, and some card slots are available. The slot in the card was not properly inserted in the slot, which caused a fire, due to which this particular chipset and the entire motherboard had to be removed. And this is a miniature fire incident. But think about major fire accidents, major fire incidents. If they don't have extinguishers and they don't know how to extinguish the fire, what will happen? This will spread. They will panic, and the fire will spread across the particular house or particular building, and they will be in a difficult position. Because I had the proper housing setup with tables, casings, and also proper spacing between the monitors and this in-house unit. I could extinguish the fire and detect the fire immediately. So careless works will be punished immediately by the technology. We cannot take risk in technology. Similarly, we have microwave technology. If there is a leak in the fire in microwave technology, it is going to create microwave losses. And side by side, the losses can be detected, but one cannot say why the losses occur. They have to go into the field and then check that there is a leakage, and it is a hazardous job. So we have risks in every job, but the risk must not be within our surrounding, where we are residing, where we are happily living. That is what I want to emphasize upon. Spoke to you about the mercury contamination. We are living on the mercury soil. We have no other go. Similarly, we are using this computers, laptops, so many devices which has got lithium ion cell, then it has got hazardous substances in them. So we need to get trained how to extinguish the fire. We have to get a fire extinguisher. However, now I am happy because I have replaced this computer with some palm tops. I am not no longer using these computers. However, in companies, the computers are used. They are very safe. Computers are very safe compared to small electronic devices. Small electronic devices, even they may get damaged, they may be mishandled, they may be thrown on the floor, they may be radiating. But computers are not such. Computers are very proper, and one can boldly work on computer in the companies. But where the what is the cause for incidents and accidents, I want to let you know now. You can see the lithium ion battery. Here you have the lithium ion battery, which is not an explosive. It will not explode unless until there is a extreme condition. I have been using the computers for around 8 years, and I have not encountered any fire accidents except for this particular board which I removed by myself. But if you see the part which can cause a possible fire spark, it is this lining. You can see the linings at the back of the motherboard. You can see all these copper coatings and the pins which are soldered. Only in these there may be a possible cause of fire due to some short circuits. Then the particular motherboard is by itself capable of extinguishing the fire, and we need not take much effort. But in my case, it was not so, because the other board, the chipset in other board was burnt, and it was inserted in this slot. When the chipset was burnt, it passed the short circuit to this slot, and the entire portion was burnt. This is how this motherboard caught fire. And once I detected it, there were plumes of smoke from the housing, and but there was not a hangama created there. We could easily spot out, and I could easily put out the fire. So the more earlier we are cautious, it is going to benefit us. And this is not wanted for every individual, and this is not wanted for me also in future, because we need not get trained how to extinguish fire, how to protect ourselves from mercury poisoning. With mercury poison in front of us and with fire in front of us, This is not wanted by us. So the reaction time when a fire breaks out and the person identifies it is hardly 5 seconds. Within 5 seconds we need to identify the cause for fire and we have to act quickly. If we miss the 5 seconds, then if it is a 1 minute or 2 minutes, it is going to rise. It is going to raise concerns with the nearby devices. For example, we have the monitors. We have monitors which are high voltage devices. Inside the monitor, a small voltage is amplified and it is going to give to picture tube, which is at 400 volts. The plates of the picture tube are 400 volts. They are not under 230 volts. This 400 volts is going to be giving the photon energy. The photon energy which is going to be impinging on the screen is going to be in the order of 1 kV, that is 1 kilovolt. And the photon energy is not going to be measured in the volts. It is going to be converted into energy and power. So in terms of power, it is going to be seen as watts energy. That is watts power equivalent to energy in time. So we do not know, or we don't know to bother about such energy conversion and power conversion, but all we know is that we feed the deflection plates with 400 to 600 volts of power, AC power from the socket. The voltage is going to be very important for the deflection plates in the picture tubes. So these picture tubes have been modified in the monitors, computer monitors, and the computer monitors are well protected with the short circuit protection, and they are very safe. But we have to take a look into the reaction times, and an individual is not given any relaxation time if there is a minor cause of fire, and individuals do not have guts or courage to face any fire incident or fire accident. One have to understand. So the pressure and the burden on the engineers increases in a massive scale when they are exposed to incidents, exposed to some accidents, exposed to hazardous substances, even though they have got some protection. So this puts a constraint on the type of job and the risk nature, and hence we have the quality management. The motherboard itself is a quality product. It is a quality product purchased from outside, and many industries in China, Japan, United States are responsible for giving the wonderful product of personal computer, which have been um, given to India through Canada. It came to India through United States and through Canada, and we are highly benefited out of the personal computers even nowadays. This is part of electronic industry only. It is not just the IT or the software industry. We use the computers, or we use the computer software, but the electronics are very important. You can see now the computer, the motherboard has got button like many components. So I can tilt the motherboard, you can see now. So what you are seeing is button like components. They are called as electrolytic capacitors. They can withstand even 25 volts of AC, or 25 volts of DC, I'm sorry. The capacitors can withstand 25 volts of DC. That means they are going to store 25 volts of DC. The rating of the capacitor says that there are 1, 2, 3, 4 capacitors in line. That means they can be in parallel, so that they are going to have the voltage capacity. Now you can also see inductive. You can also see an inductive coil near the capacitor. Here you can see the inductor. This is an inductive coil near the electrolytic capacitor. So this inductive coil is going to act along with the capacitor in terms of energy storage, and it is going to determine the charge and discharge of the entire particular section. We can also say that these are simple small choking coils. We have heard about the chokes used in the earlier light bulbs. We have the gas bulbs, light bulbs, tube lights. In that we have the choke, a very important energy storage element, which is going to be responsible for starting and continuing the energy of the bulb. When the bulb is switched off, the choke is again going to slowly discharge, and this is combination between the starter capacitor and the choke element, which is inductive. Similarly, we have the capacitors and the choke elements in the computer motherboard, which are electronic and electrical components. And we also have the some of the regulators and the jumpers. So you can see regulator diodes, and you can see some regulator transistors. You can see now the regulators where you have two pins, so they are regulators. 3-pin or 2-pin ICs, they are going to be regulators. What they are going to do is the incoming voltage may be fluctuating or it may be high, but the outgoing voltage from the regulator is going to be very constant. So this motherboard has to get the constant voltage from any source. It should not get fluctuating voltage, otherwise it may damage the motherboard chip. You can find the main chip. There are two chips. One is interface chip, another is Intel chip. To well illustrate the Intel chip, you can see now the Intel chip. You can see what you are seeing in black is an Intel chip. Now I am going to throw light on it. You can see, and there is one interface chip. You can see now the interface chip. So there are two chips. One is the Intel chip, another is the interface chip. Very important. So these chips are the heart of the entire motherboard. They are the motherboard chips, and what you can see here is a metallic case. Inside this particular metallic case, underneath this one, we have the microprocessor. So what we call as an Intel microprocessor is going to be protected by this particular element, the metallic element. It is going to radiate heat. When the microprocessor operates, it is going to get hot, but when it gets hot, there must be some mechanism that the heat is dissipated or it is radiated into air. So this particular setup is going to aid the radiation of heat from the microprocessor equally in the surrounding air. This will be taken out by a small fan. This is how the microprocessor has been utilized with the entire motherboard for proper functioning of a PC, personal computer. And the microprocessor along with the motherboard and the personal computers with the detachable units like monitors, USB, keyboard, they are very safe, and they are the best in the industry for the IT engineering as well as software jobs. However, now we are using the palm tops. Palm tops are casual devices. With palm tops we can operate from home, and we are not bothered about the big computers which are used for servers, which are used in the tabletop in the IT industry, or which are used in colleges, universities by the students or professors. Now we have the table top being replaced by palm tops, and which are going to be less productive compared to a personal computer. Palm top is less productive, but the palm top offers the safe protection units. The palm tops are very stable, and we are protected from some hazards. So better we can use the personal computers for some time, and we can also work on the palm tops for a large amount of time. This gives us a flexibility nowadays with that advancement of technology. But where where this um, particular set of files, when we have clustered computers interlinked by network cables. The network cables run through the entire length of the hall. We have so many pieces. I said that I had the fire in the small motherboard and I could extinguish it, but it will not be the case for big companies. In big companies, the networking cables are going to take the computer data information between computers. They are going to run in clusters along the walls, along the ground, along the floors nearby two computers, and the space between two computers is very important. One cannot closely spaced two computers within half a meter of distance. That means a monitor which is placed within half a meter of another monitor is going to be um, more prone to some emergency incidents than a monitor which is going to be spaced apart. So we need to take care of the spacing of two computers in a particular hall, and also we need to isolate the routers. We have to isolate the modems, which are networking elements, and the cables. Most probably the cables are a problem because a rat entering inside the hall may bite the cable, or some other insect or some other cut introduced in the cable is going to cause some short circuit, and it is going to result in a fire burn or fire incident. Not a massive fire burn or a fire incident, a small fire incident which may damage a particular system, or it may cause harm to individual. Where this cable creates a problem, there is a bunch of networking cable which is running through the ground floor, or which is when I say ground floor, it is the ground, the floor I am saying, and not the ground floor, first floor, second floor. The cable which is running through the walls. These network cables are taking data in a faster pace, so the energy through the cables is immense. Even though we can say that the cables are taking low energy current, rather than the transmission lines which are from one town to another, they are taking high voltage, high energy currents. They radiate around the transmission lines. Transmission lines are just steel wires around which there is a radiation of current, but it is not the case. It is not the case of transmission wires. These are taking low current and low voltage data from one PC to another PC over a half meter or 3 meter distance. It may be 3 meters distance, or it may even be 12 meters distance between the servers and the PC. When these particular network cables are stressed, when there is a physical stress on the network cable, there may be a possibility that the network cables may leak out some energy to other cables, such that there may be a data contamination. This data contamination can be identified in the server circuit, and it can be quickly stopped. But if the physical stress or mechanical stress is going to be immense on the particular cable such that it involves a cut, then there lies a problem. It may be a short circuit. Immediately the power goes off with a trip switch. So trip switch protects this particular network by means of isolation and a fuse. But we cannot rely on the trip switch that all the PCs are protected. Some PC may get affected. If there are say 8 PCs, one PC may be burned. The chipset in the one PC may be burnt. So one PC has to be serviced by a service technician. This is what is seen as setback in colleges, universities, or companies which are maintaining so many PCs and so many devices, electronic devices interlinked by network, as a challenge because of the space constraint. Um, they cannot deploy so many PCs and laptop computers like a large scale industry, semiconductor industry, or a leather industry, or a cotton textile industry, which is massive, or paper industry. All these industries are set up in acres of land, but this IT industry or software company is set up in a small piece of land. Maybe it may be in 2 to 3 floors or even 7 floors. But the air conditioning units, the cooling units, the firing alarm and detectors, the electrical circuit check, then the generator and the UPS setup for the particular firm have to be properly arranged. For this constraint, the IT firms and the software companies, unlike any other industry, is going to take the space constraint and manage their company within the space constraint. They are not going to exceed the space limitations, neither they are going to push themselves to a hard path of putting more computers within a less space. They are not going to create problems for the emergency accidents or incidents which are occurring. So the negligence cannot be overlooked. At the same time, it cannot be um, blamed at a particular individual or a particular person who is handling that computer or network of computers. Why? Because we have got some constraints here. I can show you the particular chipset. Can you see here? I am pointing out the pointer on the label. You can see FCC, and here you can say CE. You can see the CE and the FCC. That means this particular motherboard, it is from Intel. It is from original manufacturer. It is not from a duplicate manufacturer or some other manufacturer who uses the motherboard as a secondary motherboard. We have a primary motherboard, we have secondary motherboard. So some manufacturers directly sell their motherboard products from the industry units. So some other manufacturers, they hire the motherboards from the industry units, and they are going to give their own processor or some add-on processor along with the motherboard, and then they are going to sell it from some other country or some other industry unit. This happens. Why this happens? Because the original motherboard from Intel has passed the FCC regulations, and it has crossed the risk of hazardous substances. That means the hazardous substances made use of in the motherboard are very less compared to some other motherboard which is going to take a lot of hazardous substances in it. So in other motherboard you cannot see the label FCC or see some coded labels. Here the label is transparently given, but in some other boards the labels are coded when they are scanned with the barcode, or so they can get what regulations they have crossed and they have passed. So this is very important. If they don't comply to the standards of ROHS, restriction of hazardous substances, then the motherboards are prone to some incidents and some fire attacks or so, because of the nature of the chips, nature of the components they are utilizing. Even here you have the capacitors. You can see the capacitors. Inside the capacitors there is the oil which can catch fire. If there is a short circuit between the leads of the capacitor, it can burn immediately. There is a oil dielectric within the capacitor. So electrolytic capacitors, they contain electrolyte, but some other capacitors, they don't contain the electrolyte. They contain the desiccated semi-solid compounds in it. However, here the capacitor which are sealed by black sheath. The black sheath is a fire retardant. However, the capacitor inside has got oil in it. Not these polished bottom capacitor, but these capacitors, big capacitors, they contain oil in it. So they are very safe for us till now, but we need to take care that when there are masses of such computers, when there are so many computers, so many devices, so many such challenges crowded in a particular area, the density of the materials is the root cause of such fire incidents. It is not the single explosive type material which is the root cause of fire incident. You can see the explosive type material which was seen as the explosive type material. This many persons call this particular battery as a explosive, but I have been keeping this battery in a safer unit, enclosed by some sheets, fire retardants, for the past 18 years. This comes for 18 years. One cannot imagine. It was from 2000, year 2000, this particular battery had not been radiating, it had not been explosive, and this battery did not radiate at all. So what we hear from the newspapers, what we hear from the agencies, what we hear from some information the TV news may wrongly channelize us. However, they give information in order to make them aware of some consequences, bad consequences. But I have proven that this particular lithium battery is not radiative and it is not an explosive. So the attacks or the incidents or the fire accidents happen only when there is a density. The density of materials are the root cause of these accidents. It is not the single explosive type material which is kept in the motherboard which is causing an accident. Which is not so. Or the mishandling of some slots, so short circuits. Mishandling of these slots may cause, may trigger a fire burn. Of course, when I say fire burn, the computer is not going to burn like a fuel tanker, but there is an indication of all sorts of short circuit, overload, or even microprocessor worn out, or the memory loss, or even the slot not functioning, or the bus which has gone out. All these can be detected by means of a hardware. When we take the BIOS, BIOS indicates which is free, which slot is occupied, and which is not functioning, which is functioning in the computer monitor. So the system configuration is seen in the BIOS. So we are happy that we can detect all these changes in the computer motherboard with the BIOS settings. In the BIOS settings, we can see whether the hard disk is a failure or whether the CD player is a failure. CD player has been burnt, or the hard disk has been corrupted or burnt by physical damage or mechanical damage, or it has been attacked by so many computer viruses and it has damaged the software. All these can be detected in the BIOS. So we have provisions. It is a very safe system, but the density of the computers, the networking of the computers, the cables used, the type of hall employed, the hall form size, form factor of the particular hall, form factor of the cabinets, and the provision of for fire extinguishers, fire detectors, smoke detectors, lights, proper lights which are not going to trigger some fire in this are all important. It is not just with one type of settings we can go on with job of a software engineer or IT engineer or even electronics engineer. We need lot many settings. What can be done at home as a hobbyist cannot be done at the companies. What can be done at the companies with all protection cannot be done at home. I cannot deploy a transformer unit here, small transformer unit, and then do all these sorts of small hobbyist experiments. We can only run hobbyist experiments with a small DC 5-volt adapter. Our hobbyist nature should not spoil the living, and also it should not cause small fires within our locality. So it is better to learn all these things through internet and not indulge in all these activities at home. Home is not a place for hobbyists, especially in South India where there is a lot of mercury toxic problems. We have the mercury toxin which is going to create a problem for us in the surface layer surrounding our eyes. Now this is not affected skin, this is a clear skin, but what will happen if there is a mercury toxin? This will raise our eyebrows and it will have the effect. We can see that the surrounding eyes will be darker, the skin surrounding the eyes will be more darker, and in time we may have blurred vision, or we may even lose the eyes due to mercury toxic contamination. So the main stress on this particular topic is that technology is at its best, but it is moving towards the toxicity handling. We have to handle the toxicity better than handling the technology with our knowledge. We know everything about the technology, but we have to handle the toxicity, and we have to handle small fire incidents, and we have to handle small short circuits by ourselves. Otherwise it will create a big problem. I am not saying that we have to service all the units by ourselves, but we need to be cautious. When we are at work, we need to be cautious. We cannot sleep even for a few hours when we are at work. When the computer is running, we are not supposed to sleep at all. So we cannot expect this obedience from masses. The group of people, we are lethargic, and they are not responding to any instructions at all. People are not trained in proper manner. Whether we take our own country or our own land, South India, or even Indonesia, or Canada, anywhere, you can say that people are lethargic. They may drink coffee and they can pour it on the keyboard. They may drink some other juices and they may accidentally pour it on the keyboard's mouse, and the keyboards mouse are sophisticated now that they are being coated with waterproof material, but one cannot coat the keys with the waterproof material. The keys should have some gap on it, so these accidents happen. But what if someone accidentally person who is servicing the halls, who is mopping the halls, pours phenyl material on the chipset or a hard disk which is kept on the bench without any closure. So the hard disk will immediately damage, because inside the semiconductor materials is going to absorb the phenyl material and it is going to burn. Whereas outside, to remove the dust, they are using the alcohol. They are using the ethyl alcohol solution to remove the dust in the casings of the computers. The casings of the computer monitors are rubbed with ethyl alcohol. But the same alcohol material called phenyl may damage the entire motherboard or hard disk. So care should be taken to suppress all these mishandling activities, but this cannot be done if masses are not educated about proper handling of materials. And these problems are occurring. This is the reason for manufacturing a same type of motherboard or a personal computer or a hard disk or a mouse again and again. The production, it gives a burden on the production. We are not making the manufacturing companies rich. We are trying to increase their production day by day, and instead of maintaining just one motherboard or one PC, again and again, due to the faults in the motherboard and proper mishandling, production increases. This puts the electronic dumps in the biggest challenge. And you can see that even though this motherboard has been damaged, the pins have been damaged, the chipset have been damaged, it is not radiative, it has not caused any harm to me. It was in an enclosure, still it is dust free. You can see there is no dust on the motherboard, dust free, because it is the original motherboard from the Intel manufacturer. So it has crossed the ROHS, and it has also passed the FCC regulations. Similarly, in India, we have the regulations for the mobile phones, mobile handling equipments, telephones, equipments, telephone receivers. We have a authority called as TRAI, TRAI, Telecommunication Regulatory Authority of India, which is going to govern the regulations for the local devices being utilized at home, household devices, company devices, and e-pairbags, pairbags devices, which are going to link many phones to a particular receiver, wherein the interconnecting of phone lines is also a challenge. So the devices which have passed these regulations are going to cause less harm. I cannot say guarantee that they are not going to cause any harm. They are going to cause less harm to us compared to the devices which are not passing these standards. But one can see that if you go to a house, you can only find the devices which have not crossed this regulation or passed this regulation in maximum quantity, because we are aimed at cheaper prices. We are bothered about the costs rather than the utility and the after effects of the particular components. What we are aimed at is only cost. We have to minimize our cost as an individual. Forget about the institutions where the fire accident happened and there are so many victims. Forget about lot many companies and industries who have got so many major fire incidents. But think about the individual. We also have got irresponsible nature of minimizing our expenditure by going to cheap devices which are going to cause harmful radiations to us in the future. So we need to be educated even if we use cheaper devices. How the cheaper manufacturer of cheaper device may educate us, we have to think about it. So we need some of the agency which has to educate ourselves, because we are consumers. In the end, we are going to be consumers. So I thought about this and I had omitted some three cell phones or mobile phones at a cheaper rate because they were toxic. I found that they were toxic. This experiment cannot be done as an individual, and if we do so, we are going to be a victim of carcinogen in future. So we need to avoid, even though we are an engineer, we have to avoid all these sorts of experiments which are going to affect our health. For us, we are doing it. It is for us, of us, and by us, but it is going to affect our health also. So we need to pass some standards. The hobbyist circuit is no wonder it is going to take a 5 volt DC only. It is not going to take much voltage so as to cause an ionic radiation. From a hobbyist circuit, you cannot expect ionic radiation, but a particular circuit like this, which is massive, think about so many motherboards like this being slotted into a server system, which is a massive circuit which is going to produce ionic radiation, because the server is going to be running for 10 years continuously. The server is not going to stop, it is going to be powered by the UPS system within a particular organization. It is going to cause ionic radiation. Those who are working in server are prone to ionic radiation. This is proven, and they have to get injected by some injections which is going to reduce their headaches and migraines. They get migraines due to ionic radiations. So I want to stop with this one, giving tip regarding the safe use of the technology in handling the toxicity in our home. Because we use this technology at our homes, we are not using the technology in offices or industry units, which has got proper protection. So we need to take care of ourselves. We are not going to cross our limits of procuring materials to so many different technologies which are not going to offer us protection against some incidents and fires, or we don't have the facility to have fire extinguishers, and we don't have the training to operate the fire extinguisher if the fire is massive. So we need to take care of all these factors in shaping ourselves as a healthy person. Health is very important, whether it is mental health or physical health. The mental health depends upon the physical health. We do not know that our cranial pressure and the cerebrospinal fluid is going to be altered by ionic radiation and exposure to mercury. This is a question. Nobody is dared to prove this, because we cannot take a person at risk. We cannot put an individual to be exposed to mercury and ionic radiation and show that this is what is happening on the individual. We have so many examples naturally in the world, even in South India. We do not want to do that as experiment. So we should not let ourselves to be such a specimen to such activity. Thank you very much for listening.